All right, so what we're going to be doing today is, microphone. Excuse me, it's Thursday, October 22nd. You guys are going to be able to translate a verbal expression into a linear function, as well as a table, a graph, and be able to graph the data. You'll be able to show your proficiency by scoring a 70 or higher on the exit ticket. All right, so the first step is what we're going to be learning today, right? We're going to be learning about creating a rule, all right, or a linear function or a function or expression, equation, right? So a local electrician charges for each hour of work. The electrician charges a $30 service fee, I should say fee, and then $25 for each hour worked. Let Y equal total cost spent and X equals hours worked. So the electrician charges, so first of all, we don't really care about this statement. It does have the fact that the electrician charges for each hour, but we visit that a little later. So that knocks a sentence out that you don't have to read. So the electrician charges a $30 service fee. Remember, that should say fee, not free. And then $25 for each hour worked. All right, so for all of these problems, we're going to start off with Y equals, right? And for all of these problems, Y is going to equal the total cost spent, total amount. It's going to be a total. All right, so it also tells us that we have X equals hours worked. So notice I double underlined hours worked and double underlined hour worked. So X is going to equal for each hour worked. So when we read this again, we can say the electrician charges a $30 service fee and then $25 for each hour worked, or for each X, because X is going to equal hours worked. So we'll have $25 for each hour. Remember, when we see this word each, it's like each, per, every. Those were kind of like red flag words from when we were doing translations for equations and inequalities. So we have Y equals 25X. Remember, an X is for each hour worked. Then we have another number in our word problem, and that is the electrician charges a $30 service fee. Well, first of all, I know that I'm going to be adding everything together because I'm looking for a total, and I don't see anything that says negative or subtract or anything like that. So I'm going to be adding, and what I'm going to be adding is this $30 service fee. All right, so it's important to know what a service fee is. A service fee is like, no matter what, when the mechanic comes out or the electrician comes out, even if they don't do any work, it's just $30 just for them to come out and look at the problem. Okay, so this is the new thing we're learning today. What we're going to add to this is stuff that we learned yesterday and the day before. That's turning this data into a table. Or sorry, turning this function into a table of data, and then being able to turn the table of data into a graph. And that's your multiple representation. All three of those, the function, the table, the graph, are all three just different ways to represent this information. All right, so we'll start here. Create a rule for the following situation. So we're creating a rule and complete the table. So we have two tasks here. So Miss Beck went to purchase balloons for the math party. Each balloon cost $2 each with a $5 down payment. All right, so first of all, I'll be honest with you. I don't really care who went to go buy balloons. Sorry, Miss Beck, you're awesome. And I don't really care what the party's for. All right, all I care about is how much each balloon costs and this down payment. So you see here that we have an X and we have a Y. Again, Y is total cost, and Y is what we're looking for. Notice there's blanks here. Nothing here, nothing here, nothing here, nothing here, nothing here. That's what we're looking for. So I'm going to start off with Y equals. All right, so let me start reading. Let me really start looking into what we have here. So each balloon costs $2 each. So each balloon costs $2. Up here's our red flag word, each, with a $5 down payment. All right, so again, I see this each. I know right away that I'm going to have $2. And I'm going to have my variable here, and that's going to be for each balloon. You can also tell that here because it says balloons, and you have your X here. So you know that X is going to be your variable, and you're going to be able to put how many balloons you're going to buy, and that'll give you your total cost. It's also important to know what a down payment is. Down payment is similar to the previous problem. It's a one-time fee. So what that means is if Miss Beck did this, put her $5 down, decided she didn't want any balloons, she's not going to get her $5 back. The company gets to keep that. All right, so this is our linear function that we've formed. All right, so for this one, I'll do it by hand, and I'm going to do the rest with Desmos. So I have y equals $2, and I'm going to leave a blank here for my x. All right, I know that I'm going to put these values in for x. 1, 2, 3, 4, 5. It tells me right in front of me. It says balloons x. This is what x is going to equal. So when I put a 1 in for x, I'll get y equals. And I'll get 2 times 1, which is going to be 2. 2, and then bring down everything I didn't use, which is 5. Add your 2 and your 5, and you get y equals 7. So y equals 7. Y equals 7. All right, and if I do it for 2, I get y equals $2. I'm going to go ahead and leave this open where my variable is. That's where I'm going to put my 2. I'll put my 2 in there. Y is going to equal 2 times 2 is 4 plus 5. My y is going to equal 9. All right, for the sake of space, I have y equals $2. Leave a space here for my variable. Come up here and look, my variable needs, my x is going to be 3. So y equals 2 times 3 is 6 plus 5. And 6 plus 5 is just going to be 11. All right, and two more. I have $2. Remember, I'm going to leave a space for my variable, and I'm just writing out the equation, the linear function that I created, right? I'm going to put in my 4 here, where my x would go, because I know that x equals 4. And 4 times 2 is going to be 8 plus 5, and y is going to equal 13. All right, last but not least, I have y equals $2, leave a space for my variable, plus 5. Well, I know that in this case, x equals 5, so everywhere there was an x, I'll put a 5. Y equals 2 times 5 is 10, plus 5. Y equals 15. You can kind of see there's a pattern here. Every time this goes up 1, this goes up 2. Every time when 2 goes to 3, 9 goes to 11. It's plus 1, this one's plus 2, plus 1, plus 2, plus 1, plus 2. And that's something you'll see common in linear functions. And we will talk more about that on the next problem. Actually, we'll talk more about that. Yeah, I'll just do it the way I did it in class. All right, so now we need to create a rule, complete the table, and graph it. So we got a lot of things going on. All right, so Dawson went to a Mexican restaurant and ordered 1 burrito. That was $3.50. He also ordered some tacos with his meal that cost $1.25 each. Let y equal the total cost of his meal and x equal the number of tacos. So here it tells you explicitly let y equal the total cost of his meal. Sweet, y is total. It also tells you down here, right? Y is the total cost. Then it says let x equal the number of tacos. Here we have x equals the number of tacos. So let's see, what do we not need? Dawson went to a Mexican restaurant. Don't really care about that. But I do care about him ordering this burrito. Right? Well, I know that he ordered 1 burrito and it was $3.50. He also ordered some tacos, but we don't know how many. See how it says 1 burrito? And then it says some tacos. So we know exactly how many burritos he got, but we don't know how many tacos. We know that the tacos, cost $1.25 each. So that's our big time word. All right. So I'm gonna have 1.25 each. And it says here, X is the number of tacos, some tacos. Even here it tells us X is going to be tacos, and it gives us a value for tacos to help solve for Y. Right? So it's going to be $1.25 for each taco. And then we need to add in the one burrito. That's his one-time fixed cost. Even if he got 0 tacos, he still had to pay $3.50 for the burrito because he was definitely getting that. All right, so from here, I'm gonna go to Desmos. I'm gonna try and make this as easy as possible. I know this is a little tight. Whoops. Can't really see everything that great. So I know when the kid was younger, we used to always say, use your kid eyes. So you do that, use your kid eyes. All right, so y is gonna equal, so when we put in Desmos, the other day I was like, oh, we're gonna put in just the part of the equation that we created, which is this guy right here. I said, we're gonna put in everything except for y equals. Well, I've learned today that it doesn't matter if you put y equals because it's gonna be y equals $1.25x plus 350, right? And then when you hit enter, and we're going to say x equals, because that's the variable we're looking for, that y equals our function is then going to equal the answer. So ergo y equals our answer. So I'm going to put in y equals 1, and you'll see that we get 475 up top. So that's how much it costs if he got 1 taco and his burrito. If we say 2, it cost him $6. If we say 3, it cost him 7.25. If we say 4, it cost him $8.50. 8.5. And if we say 5, it cost him $9.75. All right. So that's all we can really do with Desmos here. So I'm just going to get rid of all of that. So we have our data, right? We've created a linear function. We've filled out our table. Now we have time to graph. So we know that this is going to be the x-axis, and we know that tacos is going to be the x-axis, and we know that total cost is going to be the y-axis. So a couple of things when you look at this graph, for you guys, most of the time when we talk about money, it's going to stay in that first quadrant. So everything's kind of going to be positive. I'm not going to say all the time, but for the most part. So tacos is going to be my x-axis. There's no numbers written, so I'm going to have to fill this in myself. So I'm going to be able to make my own graph. All right, so tacos. So I have 1 taco, 2 tacos, 3 tacos, 4 tacos, and 5 tacos. For my y-axis, I see total cost. Well, I see my lowest number is 475, and my highest is 975. I could put 475 and 975 and break it down, but I'm going to use whole numbers. All right, so I'm going to use 4. I'm going to go 5, 6, 7, 8, 9, and I'm going to go above 9 because I'm going to have to get to 9.75. All right, so we always start here, which is going to be 0, 0. All right, so we're just going to start graphing. So remember, this piece right here is the same as, remember we have x comma y. So this is the same thing. We have our x, which is 1, and then 4.75. Just because the table is pushed over or horizontal doesn't mean that it changes how our coordinate pairs or coordinate points work. Right, so I'm going to come over here. Remember the elevator rule? We walk to the elevator with our x, and then we ride the elevator up or down with our y. So I'm going to start from 0, 0, because it's where we always start. I'm going to go to 1. I'm going to go to 4, but it's 4.75. So I'm going to get close to 5, but not quite. Then I'm going to start from 0, 0, go to 2, and go up to 6. And I'm going to stop right where 2 and 6 intersect. Then I'm going to go to 3. I have to go to 7. I have to go just a little bit past 7, because it's 7.25. And when you're doing stuff like this, it's okay to guesstimate, right? Especially when you see these in real life or on an exam or a test or exit ticket or whatever, you know, they're going to be in between the numbers. So you're going to have to kind of use your better judgment. All right, I go to 4, go up to 8.5, which is right in between 8 and 9. Then I go to 5 and go to 9.75. So I come to 9, go past it. I get close to 10, but it's not quite on 10. All right, so here's where I pointed this out yesterday. It's important to notice, now we've graphed all of our points. But remember, this is a linear function. Notice that this line goes through all of our points. Right, so I want to write out the word linear. Notice it has the word line written right in it. It means that this line is going to work for all these points. Let's say on accident, I misgraphed this point and it ended up being like 9.75 and 5 or whatever. And I had a point way out here. Notice I can't graph one line with these points. So that would mean that you would want to recheck your work. All right, so let's try something a little bit different here. So the table below shows how much Jen will earn for working different number of hours. Which graph best represents the relationship in this table? All right, so there's a couple of things here that you guys really want to look at. First of all, we have hours worked. So is that my X or Y axis? Well, let me come over here and look at these graphs. I see earnings, I see hours worked. So this is going to be my X axis, right? And I'll write it on all four. Then I see earnings, come over here, I see earnings. So this is my Y. Sorry, earnings is my Y. And you can label these. From here, it's just basic graphing. You're gonna start at 0, 0 like we always do. And we're just gonna graph. So we're gonna come over to 1. Oops, sorry. We're gonna start at 0, 0, we go to 1. We're gonna come up, we're gonna touch the graph. Once we touch the graph, we're gonna go to the y-axis and see where it meets up, and it meets up with 3. So this point is on the graph. So this looks like a good point for A. Come over here, check out number 2. We're gonna go up, touch the graph, go to the y-axis, and you see we hit 6. So 2 and 6 pair together. So that's gonna be a good point on the line. And we do 3, we go up, and you go to the left, and we can see that we hit 9. And that's going to be a good point on the graph, on the line. So A is probably our answer, but we're good students, so we want to double check. So let's check out B. We come to 1, we go up, we go to the left, and we get to 6. And we needed 1 and 3 to be friends. B is not the answer. Go to C, start at 1, go up, go to the left. Once you hit the graph or the line, you see we get to 9. We want it to be 3, C is not an answer. And the same thing for D. Start at 1, go up, and we'll see we hit 12. So D is not the answer. All right, last but not least, the media club is selling bags of popcorn at the football game. The club pays a one-time fee to rent the popcorn machine and supplies. Use the equation y equals 2x minus 30, where x represents the number of bags of popcorn sold and y represents the club's profit. Which table represents this situation? All right, right away, let's get rid of some stuff. I don't care about the media club selling popcorn or the football game. I also don't care about the one-time fee to rent the popcorn machine because they don't even talk about how much that was. All right. Well, technically they do, but they give us the equation. So all of this is kind of like a moot point. So from here, we're going to use the equation y equals 2x minus 30. All right. And that's where x represents, this is the important part, x represents the number of bags of popcorn, and y represents the club's profit. All right, so let's look for our x first. So x represents the number of bags of popcorn. Bags of popcorn. These are my x values. These values right here are what I'm going to put into Desmos after I plug in my function. Right, I'm going to put all of these values into this function, and what they need to do is they need to yield these values. And the reason is because y represents the club's profit, right? So these are my y values. And this equation is saying that whatever we put in for x is going to give us y. So for here, I'm going to type in y equals 2x minus 30. Remember, we're using x, so x equals. So I know you can't really see, but x equals 0 gives me a negative 30. Well, on A, I get a negative 30. B, I get a 0, so B's out. No, we don't need to worry about B. C is negative 30, and D is negative 30. All right, so those are all still contenders. So now we want to try 12, because 12 is our next x value. And notice all of our x values are the same in all 4 of these tables. When I put in 12, I get negative $6. All right, so A looks good here. C says it's 18, so C is wrong. D says it's negative 28, that's wrong, so A is our correct answer. And you could double check the rest of them just to be sure. So we have 24, you'll see we get 18. And when we try 36, we get 42. And that works for all of them. All right, so A would be our answer. So that's it for Desmos for today. And the last problem, I'm not going to bother with this table because I feel like you guys are comfortable enough with Desmos. And if you're not, feel free to hop in for Raider prep or office hours, or just send me an email. Like I'll work with you. All right, so we need to come up with an equation. Complete a rule, create a rule for the following situation. All right, so Pacey bought a teddy bear for $7 for his girlfriend Josephine. He also bought bouquets of roses for $18.50 each for her. All right, so let's see. We know that total cost is Y. We know that bouquets is X. And remember, if total cost is Y, we start off with Y equals. Big key word here is each. When I see that word each, it means that I'm going to multiply by something. I'm usually a variable. So he also bought bouquets of roses. So bouquets here are going to be our X for $18.50 each. That's going to be $18.50 for each bouquet of roses. Then it says he bought a teddy bear for $7, right? A teddy bear for $7. Remember, we're going to add because this is the total cost. Obviously, he's getting her flowers and a teddy bear, but he only bought one. He bought a teddy bear. It doesn't say he bought a couple, a few, 10, or how many. It just says a teddy bear. So we can infer that that's going to be one teddy bear. And this would be your equation, right? This would be your linear function. All right, so hopefully that was helpful. If you guys have any issues or questions, feel free to reach out to your teacher. Tomorrow we have, what are we doing? Oh, we have a pretest. So you guys will be doing that. If you need any help, email me, Schoology message, whatever. Have a good afternoon, good evening, and I'll see you guys tomorrow.